I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on plane waves in free space for the CLT lecture series on electromagnetic fields and waves. And a plane wave is a wave where the amplitude is constant over any plane perpendicular to the direction of wave propagation. In other words, the wave fronts are infinite parallel planes. This means at any given time, the value of the wave is same on any point within a given plane. And nature of plane waves are transverse in nature, where the electric field and the magnetic field are at the right angles to each other and also to the direction of wave propagation. So the direction in which the wave moves is called the direction of propagation of electromagnetic wave. So the wave maintains the same amplitude and direction across any plane perpendicular to its motion. So, and in the picture, you can see a free space wave, a uniform plane wave is traveling. So here, free space means a perfect vacuum where no obstacles, no charges, and no currents. Electromagnetic waves in free space has no resistance, no attenuation, and travel at the speed of light, and it is the ideal environment to study the electromagnetic waves. And now the free space conditions we know, it is the permittivity, and which is the where the electric field is accepted by the given medium is epsilon naught for free space, and the permeability, the magnetic characteristics of the free space is mu naught, and the resistivity is 0, conductivity is 0 because it is dielectric, and the J, since conductivity rho is 0, we can say the J value, that is the current density, is also 0. And Maxwell's equations for free space, there are four Maxwell's equations we know. Maxwell contributed great to the electromagnetic waves because he formed the four mathematical equations, and these four equations proved the existence of electromagnetic waves in free space. And since the free space, there is absence of charges and currents, so the Maxwell's equations becomes del dot E is equal to 0. This means there is no electric dipole, and del dot B is equal to 0, which means no magnetic dipoles, and del cross E is equal to minus dou B by dou T, and the fourth equation del cross H is equal to dou D by dou T. And these four Maxwell's equations are derived from various laws like Faraday's law, Ampere's law, and also Gauss' law for electric field and Gauss' law for magnetic field. And now the propagation characteristics are very important for any wave propagation. And if we take plane waves, they travel in straight lines with constant speed and at free space. And the energy carried by the wave moves forward continuously without loss, and the wave does not spread out like circular or spherical waves. And since we are dealing with plane waves in free space, the electromagnetic wave equations are very important. So the two electromagnetic wave equations are, one is del squared E is equal to mu naught epsilon naught dou squared E by dou T square, and another one is the magnetic field wave equation del squared H is equal to mu naught epsilon naught dou squared H by dou T square. And now the plane wave electric and magnetic field formation is, the electric and magnetic fields are tightly linked, and a change in one produces the other. They oscillate as the wave moves forward, but always stay perpendicular to each other. And the strength and direction of these fields stay uniform across any plane of the wave. In the picture, you can see the electric and magnetic field directions. They both are perpendicular to each other and also perpendicular to the direction of wave propagation. And here the activity as a break to you. And a very important applications and the plane waves, how they are used to us in our day-to-day life is the plane wave concepts are used in antenna design and analysis, because we know the antenna is a device which transforms the fields from electromagnetic waves from one place to another place. And in the design of antenna and analysis, we must know the plane wave concepts. And they are widely used in wireless and also satellite communication. And they are used in radar systems and in optical fiber communication and laser system also. To study the plane waves are important because plane wave concepts are involved in optical fiber communication, how the signal, electromagnetic signal is traveling through optical fiber, how it's get attenuated and how it is transformed from one place to another place. And in order to know the concepts of all these important emerging wireless applications, we must know the plane wave concepts. And not only that, the plane waves are also helps in understanding how the signals travels through air and also the vacuum. And also the uniform plane waves is a very idealized case. It can adequately model many practical situations in wireless communications, radars, etc. For examples, fields impinging on receiving antennas which are far away from the transmitting antennas are practically uniform plane waves. Now the assessment questions. The properties of uniform plane waves, we know the important property where the electric and magnetic fields are perpendicular to each other in uniform plane waves and also perpendicular to the direction of wave propagation. And the electromagnetic characteristics of plane waves also we have studied. We have seen four Maxwell's equations and how it is modified for these uniform plane waves in free space. And next is the importance of uniform plane waves. We have learned how the concept of uniform plane waves applied in all the emerging wireless communications. And these are all the assessment questions. References.